All right, welcome ladies and gentlemen. My name is Brian McLogan and this is week 49 open Q&A. And on tonight's live stream, I want to talk about when to take the L in your classes. So thanks so much guys for joining me in tonight. I know some of you are busy away getting ready for your exams. And I know some of you even submitted some questions that for me to be able to address. Hopefully this is a very important stream for you and I am going to get to your questions. And again, if I do not get to your questions tonight, remember I do have a Discord server that is in the description that you can go ahead and submit into there. I was able to get some things cleaned up for the server, and so therefore it is a little bit more organized as far as your courses that you're taking. And I am just looking into building up more and more of a community because obviously, ladies and gentlemen, I am one person and I'm not going to be able to get to everybody's questions as much as I would like to. I don't even get to all the questions that get submitted to me. If you are interested in submitting a question for me to go ahead and address every Sunday night at 9 p.m. when I do my live streams, if this is the first time you joining our live stream, then you can go ahead and do that. That is going to be in our as far as in the, that is going to be a live stream in the, what was I talking about? I don't even know what I was saying. I lost my total train of thought. But that will be in the description is going to be a link to that. And Melinda, please let me know, because Melinda has been one of the moderators in the Discord, who obviously has been putting in a lot of the work to make that all work out on Discord. Can you actually go ahead and check for me as far as on that Discord? Let me know if that posted on there, because I wanted to make sure there's a connection between the YouTube and everything with the Discord. So as far as those of you guys that are in there and you're looking into the live streams, or if you want to refer to them, all the questions that I do cover in tonight's live stream will be timestamped. So therefore, if you are looking at any post recording of my live streams, obviously you'll see at the beginning of the live stream, I am, going to be addressing a question like tonight is going to be taking the L in your test or exam or course. But I also want to make sure that you, but then I go ahead and answer questions after that. And those questions are going to be organized and then everything else. It did not post. Dang, Melinda. All right, I guess we'll just have to figure that out. I did see that there was like a YouTube bot and I'm wondering if that maybe needs to be another thing. So we'll go ahead and take a look at that because I did post a post in there. So I guess that'll be just another thing for to go ahead and trigger for on there. So thank you so much for doing that. And again, Melinda is awesome because she has really been the one that got everything all set in the Discord. It is awesome. I think for those of you guys that have not been to there or maybe have never been on Discord before, I think it makes a lot more sense now. And it's much more organized for you guys to answer your questions. And also, again, as I mentioned, guys, when you're going in there answering questions, always looking to be able helping people out. I truly believe in all that. So, Qui-Gon Jim, I do not teach physics, and I'll actually be talking about physics in this live stream here coming up, but I just want to say a little bit hi to Alvera, Addie, good to see you, Andarin, is Tarina, are you taking questions now? No, I do have a couple points in this live stream. As you guys can see, after I kind of go through a little bit of an introduction, I do have some points in there where I just kind of have open questions, so I'll go ahead and address them, but the thing is, guys, and people are always, one of the reasons why I go to these submissions is because for people to like type this into the chat, I mean, obviously if the chat's moving really quickly, it's very difficult for me to be able to write them down, and post them in on there. It just takes a lot of time. So that's why I always just provide, not only for you to type it into the chat and then for me to write it down in the chat to cover it. It's just a lot. So that's why I always recommend that you pre-submit your questions if I'm going to get to them. However, I am more than happy to, kind of address maybe some general questions for on students, or even sometimes the open one that like Born to Win says, how don't be shy of a teacher? That's actually a very interesting question. And I'll actually, maybe on those, if you maybe will repost that, I will definitely remember that. Ready V, Samantha, good to see you. The Programming Nerds, hello. Julia, good to see you. Daniela, I wanted to mention you, Daniela, because I saw your question And I was like, I should know these, but it's been like 10 years since I have covered geometry. So I do not recall the circle theorems, or not the theorems, but the circle formulas and all that kind of stuff. So I apologize. That's something I'd have to go back and research. I'm teaching geometry this year. It's been 10 years since I taught geometry. So I'm not going to be getting to that. We're not going to be getting to that until later in the year. So apologies. I just don't remember those formulas and everything like that, but we will be getting to them. But yeah, that's definitely, I would just look into those like arc, major arc, minor arc, all those different types of formulas. Those questions that you submitted, that's what you're going to want to be looking at. All right. How do I like math again, avocado? Yeah, it's definitely a little bit of a balance, I think, as far as finding the, this idea of like enjoying doing the work, but then also not being stressed. And that's what I wanted to cover with you guys as far as like taking the L, because I definitely have something, that I wanted to bring up, a couple different perspectives, one from the teacher and then one from the student, and then one just from you guys on there. Okay. So first of all, the reason why I talk about taking the L, it's just taking the loss, giving up, just failing, a test or a quiz. I have a lot of students, and obviously I teach, pre-calculus has been one of my major courses I've been teaching for a while. And, but it doesn't matter if it was when I was teaching calculus, or Algebra 2 honors, or Algebra 2 standard, or geometry. A lot of students, they have stress. All they want to do is get A's, A's, A's. And, it'd be great if every student was like perfect in every single, if a student was perfect in every single, study or a course, that they're taking, but it's just not the reality. We all have our strengths and we all have our weaknesses. And I don't want to downplay the idea of giving up in like a course or on a test and not trying your hardest. Like, you should put in the effort to do as well as you need to do. But in the same thing, like, it also kind of comes into me like the idea of like the Bo Jackson idea, the two-sport athlete, playing football and baseball. And I know I might date myself a little bit on this, and some people have no idea who I'm talking about. But, this idea of like, you're going to be an athlete. Like, for instance, I played 3 sports when I was in high school: football, wrestling, and baseball, right? And I was a decent athlete in all 3 of those sports. But, in the same respect, I think it was very important to have all 3 of those sports because it gave me a variety that I needed to become a really good athlete. But in the same respect, like, if you are going to, like, if your major goal is to really, focus in on really like going into mathematics or going into writing or anything else, you don't need to be really as concerned as far as like getting a possible, A for whatever course, or, making sure that you always have the best of the best. You're always the top. And I feel like that's what a lot of students, I don't want to discredit, not putting in the effort or getting the best grade, but I feel like what I'm seeing from this, and the reason why I wanted to talk about this, is I see so many students have so much stress because it always feels like they're always in constant competition with other students to be the top or to be the best, and, a lot of students, especially in math, like, they're not ready to excel in mathematics. They don't have that mental maturity. And yet all they're doing is just doing these tricks, these gimmicks, these, cramming studies just to get the best grade they possibly can. Even though they're not focusing in pre-calculus, they're going into like medical or, something else. But they just have all of this, they're just putting so much of this time into a course where it's like, you're not need this course. Like, you just need to get by this course. You just need to get a good grade, right? Maybe not the absolute best grade you could possibly get. And I think for a lot of students, that's enough, and again, I don't want to blanket advice for everybody because everybody has different situations and different circumstances. But that's something that I have seen with a lot of students is they just burn out trying to get, the best grade possible in every single course. And, while there's nothing wrong with, obviously excelling to your finest potential, in the reality, you're never going to be the best in everything, right? And so it's important to really kind of identify what it is you have your strong suits in, what do you want to continue advancing, and make sure that's going to be your focal point, and not to just give up on everything else, but just kind of realize that those are kind of in your supporting realms and you have your main focus. And, I kind of bring this up into a personal story that I kind of mentioned in my email earlier today. Someone was asking about physics. Like, no, I don't like physics. I really don't. I'm not a very applied mathematics type of person. I'm much more in the pure mathematics kind of realm. That's what I'm interested in. And I didn't really know that when I was first getting started. So I thought I'd be a math major and a physics major, and everything would be like, they would just work. And I struggled, taking, I think it was like Calc 2 and taking a physics course. I was just struggling. It was just so, and then plus my other courses that I was taking. So it was just so much demand on me as a student, and I started falling behind. And, that was my point where I finally decided, I'm like, I just got to give up on the physics. Like, I can't put in as much work into, my main focus is getting my math major. Like, it's not physics. That's just, some minor that I decided on. So, that was my point where I said, hey, you know what? I'm just going to take the L on this. Like, I gave up on that course. I came back to it and eventually, got a C. But my point was, I was not concerned about getting a C. I was like, I just need to do whatever I need to do to get a passing grade for this course. I'm never, obviously physics is important in mathematics. We do a lot of problems in calculus and and even in pre-calculus, that are helping these physics students. So I need to know what I'm doing, right? But I'm like, I don't need to put in as much time trying to be the top physics students in that course. I need to do what I need to do to get passed on that class. And then therefore I can focus on my other courses that are going to be more important, for my major as well as for my education. And that's something that served me, very, very well. And, so I just bring that up, up to you guys as you're getting into these courses. So many students are taking all these exams, and, you're focusing on all these different courses and how much studying. And, I just think it's just very important, especially with a lot of the demand and stress that I see from a lot of students, is for you just to kind of, take a little step back and just kind of realize, what it is you want out of each of these classes. And, if your main goal is to get all A's and, be the top of your student, then, that's fine. I'm not gonna downplay anybody's, intentions and their goals, but I think for students understanding what it is they want to get out of that course and really trying to focus in on saying, here is where the direction I want to go, which again can change. Definitely can change, but it's like, here's the direction I want to go. This is going to be my main focus. I want to put everything into this focus. And then everything else is going to, obviously I'm still going to put effort. You just can't give up, because then you're just going to, if you're only focused on one thing, you're just going to get burned out. Right. Or more likely, more often than not. But yeah, everything else is going to be that support role. You're still going to put in the effort to do what you need to do. But I just see so many students that they aren't set up, like, just real quick before I get into your questions, I have students that are like, oh, it takes me forever to do like math problems. And I'm like, yeah, it took me forever to do like English papers. I literally would take, I knew when I had to write an English paper, it would take me like 3 versions. It would be like 8 hours later. And then finally I would be able to get that thing done, So it's like, you just got to kind of know yourself and kind of understand what it is, you are best at and what you want to work towards. And hopefully that is something that, that will benefit for you guys on that way. So, all right. If I could yell, I would. Well, I think I got him timed out, or whoever that was. There you go, Melinda. I can actually, wow, he was quick. Whew, yeah, I know. He got right in there. You gotta, how do you feel about if you catch somebody cheating? God, I don't know why you guys kept on cheating. Yeah, I haven't caught anybody cheating this year. I've caught students cheating last year, for sure. And usually every year I always catch students cheating, but if you guys look at my live stream, 2 years ago, like a couple weeks ago, like I always mentioned, like I give students a cheat sheet, on their test, and there's other ways that I help my students in their grades. Other things that I do to like really help them out, but still students take that, take that approach. And yeah, I don't like cheating at all, like, especially for all the things that I do inside my classroom for students to be to succeed, yeah, it really actually makes me mad, as a teacher. Because I think if you do what you need to do in my class, I provide basically everything you need to do to be successful. So yeah, I kind of take it personally, which I don't think you should as a teacher, take it personally. I think you got to understand kind of understand a little bit why the students are taking, especially if you're offering all of these opportunities for them to be successful, why are they taking that route? Why are they taking that risk? And yeah, I mean, our school, it's a referral, and, I usually, depending on the severity and what it is, call home and referral, and yeah, it can be very serious depending on it. So, typically I've only seen the, cheating on little pop-up quizzes and everything else. And I've only caught somebody once, and that's never been an issue ever before. Or typically, if there's always a suspicion that somebody's cheating, they kind of know that I am watching them, and that usually qualms things, as well. Even before I actually catch them, I can kind of see that my suspicion is up, and then they kind of notice a little heat on them for sure. So, but yeah, I'm taking geometry and algebra too. Okay, great. All right, guys. So let's go and get into the questions. I will definitely be taking in any other of your. Yeah, Jaden, I get a lot of for the Johnny sins. Thank you. I don't memorize equations, Meryl. Not at all. I just practice and do a lot of questions. And I feel like that's the best way. If you're doing it if you're doing something that often, then you need to know it, right? If you're not doing it, for instance, Daniela asked me questions like circle theorems. I'm like, I haven't taught geometry in 10 years. I don't remember these circle theorems. That's a very hyper specific, theorems for that course. And obviously it's not just for geometry, but it's, those are where they're primarily used. And as far as my teaching, I'm not using them all the time. So yeah, I would, I'm not memorizing them. I just have them for written down. All right. So let's go and get into the math questions so we don't get too late on that. And best of luck for all of you guys on the questions. Again, guys, if you do have questions for further live streams, you can definitely go ahead and submit them into the Google form that is posted in the description. Or if you want a little bit quicker access, there is a Discord server that you guys can go ahead and join on from there and go ahead and post your questions, as well as help some other students with their questions. So let's get on to the first one. I will have a couple breaks, guys. Every 5 questions, I usually take a break and we'll say hello, as well as address any other questions that you guys have. All right. So this question is, so suppose that tan of A is 7 or 24. What are the values of the other trigonometric functions of A? And actually, I didn't even check that. Let me check something. 20. Yeah, that's what I thought. Okay. So if here's a triangle, let's see what I got right. Yep. Okay. Okay. So it's a right triangle. So here's our angle A. So this is 7 and that is 24. Using hopefully you recognize this is a Pythagorean identity. You could use a Pythagorean theorem, but you're going to get 25 there. What are the values of the other trigonometric functions? So we have tangent is opposite over adjacent. Let's see, we have sine of A is going to be opposite over hypotenuse. Cosine of A is going to be adjacent over hypotenuse. And then you have the reciprocal functions. Cosecant of A is going to be 25 over 7. You have secant of A, which is going to be 25 over 24, which is going to be hypotenuse over adjacent. And then also you're going to have cotangent, which is adjacent over opposite. So that's going to be 24 over 7. And then they asked another question, given the cosine of an angle is 0.75, so we could say, let's just say cosine of theta is equal to 0.75. And then it says, write the expression for cosine of the half angle. So I do not remember the half angle. I'm going to be teaching it here rather soon, so I'm just going to kind of go through what I remember. So it's plus or minus depending on the angle, which we don't know. So it's going to be +1 plus cosine of theta divided by 2. I think that's the half angle formula. If anybody wants to go ahead and do a quick search and just give me a thumbs up, that's the half angle formula. So I'm not sure, no calculator needed, exact expressions only. So, I mean, I guess if you're just going to plug that in. So we already know that the cosine of theta is going to be 0.75. So 0.75 divided by 2. And I guess since 0.75 is going to be in the first quadrant, if cosine would be 0.75, then yeah, because it'd be negative in the second quadrant. So therefore it has to be the first one. So it'd be positive. Nobody's confirming for me yet. What's up? Yes. Okay. Thank you. Sweet. And then, yeah, you could simplify that a little bit further, with your angles, but I'll just keep it, from there. All right. Next one comes from Sarah. It says, the best way to study for honors, Algebra 2, and any tricks you can make it easier for me. I do have something actually, Sarah. The reason why I picked this question is a little bit different from Algebra 2. One thing I remember when I was learning actually college algebra compared to Algebra 2, but it's kind of the same thing. I mean, I've taught Algebra 2 for many years, but one thing that, kind of stuck out with me from Algebra 2 is just to keep on doing your spiral review. And, obviously I have a lot of tricks on how to study and everything like that, but I really think it's very important for Algebra 2 that you're just doing a spiral review. What I mean by spiral review is once you've kind of finished a chapter or even like a section, just to go back and do a couple problems. Like literally, if your teacher doesn't already do that for you, which they should, just go back and just constantly be doing some older problems because, Algebra 2 is one of those that you just keep on, it's one of those you just keep on building up on older topics and you see these relationships of like, oh my God, we learned this now. Like it's actually, that's the exact same thing we learned previously. And, when we were dealing, the radical function or the logarithmic function and everything else, and you really start to see these connections. So I would definitely do spiral review. Just, it doesn't need to be anything crazy. On my homework that I have for my pre-calculus students, I think I have 4 questions. Every night they're just doing 4 questions that are from previous topics and that they just to kind of remind them and keep them fresh on the content and the information. And what that does is just 1, it helps you not forget stuff. And then 2, it just builds on those connections. Okay. So I think that would be very important, especially for an Algebra 2 course. It's true. It would be true for any course. I mean, I could give that advice for anything, but immediately once you said, studying for Algebra 2 honors, I was like, this I just really see is helpful for Algebra 2 honors, which it's a little bit special and different than what I would cover maybe for another course. The next one is solve for x. And so the one thing you need to remember is the triangle angle interior sum theorem, which basically says all the angles in a triangle add up to 180, right? So all these angles add up to 180. So therefore, remember, if you have x and you're trying to solve, you need to set up an equation. So you need to look at that relationship of these angles. So that's going to equal 180. All right, so 3x plus x is 4x. So that's going to be a 6x. Let's see, that'd be negative 22. So that's going to be a positive 28. Equals 180 minus 28 minus 28. 6x equals 152. And let's see, that's going to go, is that not equal? So that'd be 120. That'd be 32. I wonder if I did that right. Right? Let me just double check my work unless there's nothing wrong with getting a fraction here. Oh, I did do that wrong. That's 18. Come on, Mr. McLogan. Yeah, that'd be 22. 40 minus 17. Yeah, 18. I'm an idiot. And why am I subtracting 25? There you go. Minus 18. There you go. That'd be 142. All right, minus 18. Sweet. So that would be 7162. There you go. Divide by 6, divide by 6. So 6 goes into, I don't know, my brain's hurting. I don't even want to do the math anymore. I'm just going to give up. I'm going to be lazy and use my calculator. Sorry. So x equals 27. All right, let's go another one. So the next one says circle the equations that represent the quadratic relationship. So again, guys, if it's quadratic, you're going to have it. Here is your parent graph. So it needs to be in some variation or form of x squared, okay? So that is linear. So it's not that one. Here, quadratic. Yep, that works. Quadratic, right? You have t, doesn't matter if it's x, y, z. That's good. Nope, that's cubic. That's a squared, even though like if you were to expand x minus 1 quantity squared, if you were to expand that, you'd still get an x squared as the highest power, so that works. And then this one has an x. So nope, that one does not work. So those are going to be your 3 options. All right, guys, now it is on to a open. So hey, star 177A Tony, Good to see you. And Jack and Art and Aiden, how are you? Sarika, Ed, GamerCube, yep, let me know if you guys have any other questions or anything else I can do. I can maybe kind of see if there's an open question I have. I just made some black coffee. Oh, man, the days of studying for my exams. I don't miss it one bit, but I know you guys, the one thing I just would encourage you is, you know, you got a long week ahead of you. For those of you that still have exams this week, get it done, do what you need to do, and then it's over with, you know, at least for a couple weeks, or depending on your class. That is the half angle format. Sweet. So Art Boys, do you have any tips that you know be helpful for all of us, for all classes? I mean, yeah, I mean, whatever tips I just went through, the general. I mean, if you look at my last couple of streams, if you go to my channel and just look at my streams, you guys will see that I have a ton of questions, you know, a ton of examples to help you as far as study and prepare and stuff like that. Dennis, I do not know how to answer what to do. And GameCube, yes, I did. Nicole, and let's go. Can you do quadratic equations? We'll be doing some quadratic equations. What topics do you do? I do as much as I can, but basically everything through high school. Algebra 1 through calculus, I'll be able to do. I'm done with my finals, Calc 3 here. Good for you, Melinda. That is awesome. That is a very, very good feeling. All right, Art, I got you, as I mentioned. So let's just do some extra tips since Art, you only need to, well, we'll post on one. So what are some extra tips? Do you have any question we can ask? Yes, you can post your questions every time I have an open stream. You can go ahead and post your questions. But let's go and see, Art, what are some other tips I can do? I mean, I think the main thing, guys, is you have to practice. Okay. Actually, you know, let me kind of give you what I tell my students, one thing that they were, you know, doing. So when I say show up, okay, what that means is obviously attention. What I mean is show up. So that means it's going to be attention. Okay. Notes, obviously, like the basic things, like, hey, show up, but obviously be like, not just be show up, but like be present. Okay. Not only that is you're going to have to put in the work. Okay. So that means to practice doing the problems, like, you know, do extra problems, whatever you got to do, but you got to put in the work. And the last thing is going to be reflect, right? And review. So I think there's that one thing is obviously like taking that step forward. You know, there's going to be times you're not going to want to show the class. There's going to be times that you're going to get notification in your pocket and you're just going to want to look at it and you're going to want to get distracted. Make sure that you are showing up, that you are present in your class. Okay. So tips for learning. I just want to do this for my timestamps. Okay. So show up, attention, make sure you are being present. The next thing is put in the work. You got to do the practice problems. You have to go ahead and do, you know, the review problem, spiral review, doing your homework and, you know, study and all that kind of stuff. Like just put in the work, you know, and if you don't, there's eventually going to be a class that you're going to have to do that work, right? It's eventually going to catch up to you if you can maybe get by and it's, you know, not requiring for this class. Maybe when you get to the next class, you're like, oh crap, I don't know how to study or prepare for a hard test like that. And the last thing is reflect. Like when you get your test back and your quiz back, reflect on what you got wrong, why you got it wrong, right? Reflect what you understand, what you don't understand. And I think there's that mental idea of, you know, understanding where you kind of stand in the course and what you're understanding is very, very beneficial as far as you moving forward with the class. All right, so now let's go ahead and get in. So question number 3. This one says, simplify the given trigonometric expression and express it in terms of the second expression. So, I can't remember who posted this, but they said, like, what does this mean? So this is going to be an identity. Basically, another way you can write this is 1 minus cosecant squared of t divided by sine squared of t minus 1 is equal to cotangent of t. Like, that's basically what that's meaning. So, crap, if we remember our identities, so one of our main identities is the Pythagorean identity, right? So sine squared of t plus cosine squared of t is equal to 1. Okay, so let's see here. If I want to write sine squared minus 1, so I could say based on this, I could say sine squared minus 1 equals, oh, that's of t, equals a negative cosine squared of t, right? If you were like to subtract the cosine and subtract the 1, okay? So I can put a negative cosine squared of t right here. And then how could I rewrite 1 minus cosecant? Well, think about this. If you divide by a sine on both sides, sine squared of t, divide this by a sine squared of t, and this be divided by sine squared of t, that's 1 minus a cosecant squared. And what does that give you? Cosine over sine. Cosine over sine, that is going to give you a cotangent. No. Cosine over sine, yeah. It's going to give you a cotangent. That's not what I want. 1 minus cosecant is a cotangent. Oh, cotangent squared. Okay. So it's going to be a cotangent squared of t. All right. So therefore, this is cotangent squared of t. All right. So what I would do then in this case is I would, let's see here. Let's rewrite this as cosine squared of t divided by sine squared of t divided by, see, how's that going to give me a negative? That's supposed to be a negative cotangent. Okay, that's a negative. Divided by cosine squared of t. I am not seeing. Something's not. Sine squared by cosine squared equals 1. I didn't look at this one. I thought when I mentally did it in my brain, mathematically it worked. So if I subtract 1 and then subtract cosine, that gives me a negative cosine squared of t. Yeah, and if you're going to get a cotangent, all right, now you guys are going to get me thinking on my brain. So let's see, cosine squared of t plus cosine squared of t equals 1. All right, so if I want to get cosecants, then I would divide by sine. So if I divided everything by sine, I get 1 plus cosine over sine is cotangent squared of t equals cosecant squared of t. Okay, so that's a negative cotangent. Yeah, that's right. That equals a negative cosine squared of t equals cotangent. Simplify the given expression and express it in terms of the second expression. Oh, no, it's not an identity. I think it's just writing it in terms of cotangent. Okay, so then how could you write I'm not really, simplify the given expression and express it in terms of the second expression. So I am writing it in terms of the cotangent, I guess. Yeah, it's not supposed to equal cotangent. I guess I did misunderstand that question. But at least therefore I am writing the expression in terms of the cotangent. So it's not fully in the terms of that cotangent question. Cotangent of t divided by cosine of t. But at least hopefully that gets you started for somewhere in there. I'm not sure what else I would want to do with that. What else I could do. I don't know. My brain kind of hurts with that one. Not really hurts with that, but I'm trying to think of what else I can really do on the fly. And seeing anything else? No. Okay. Make more noise for mirror also stimulate your brain. Thank you. Okay, so next one says x minus 6 quantity squared plus y plus 3 quantity squared equals 2 to the 10th. What the heck is 2 to the 10th? I don't remember 2 to the 10th. 2 raised to the 10th. Okay, 1024. Okay, so it says find the circumference. So circumference is going to be 2 pi r, right? Okay, so we got to find r. So remember the equation of a circle, right? This is the equation of a circle is going to be x minus h quantity squared plus y minus k quantity squared equals r squared. So that means 2 to the 10th, sorry about that, is 1024. So that means r squared equals 1024. Well, for the circumference, I need to figure out what r is, right? So I'm just going to take the square root of that answer, and that's going to give me 32. So r is equal to 32. However, when you type this in, so secant or circumference equals 2 times pi times 32, which equals 64 pi. So that's why that is your answer. All right, determine whether the inverse of a function, or each of the following function is a function. Explain your answer graphically and algebraically. Well, so yeah, I think the student was asking like as far as the horizontal test, because when you have a function, let's say like this, when you go ahead and reflect it about the y equals x line, right? What's going to happen is if it doesn't pass the horizontal line test, then when you reflect it about the y equals x line, it's not going to pass the vertical line test. That's what we'll call a one-to-one function. So if it's not one-to-one, the function is not called invertible. So in here, we have a line, right? So you could rewrite this as 1/2 times 3x minus 4. Well, that's going to be a linear equation. So that is definitely invertible. That's one-to-one. This is a quadratic, and you would say, well, that's not one-to-one, right? You just showed us a quadratic, but it does have a domain restriction. And if you were to find the vertex, which I guess we could just complete the square here, x squared minus, let's see, 4, or actually, we're going to do some completing the square here in just a second. So let me see if I can do this. I can't probably do this in my head, but maybe I can. X minus 4, right? 8 divided by 2, that's 16. X minus 4, quantity squared, minus 16. So that would be plus 6. Completing the square in my head. Okay, and therefore you can see what that's doing is that graph is actually, this graph is being shifted to the 4 and 2, 3, 4, 2, 3, 4, 5, 6. So it's only for x values that are greater than 4. Well, you can see that's only a portion of the parabola. So therefore it's still going to be one-to-one. So therefore that is invertible as well. This one does not have any restrictions. I don't know what the vertex is. I'm not going to complete the square in it, but I do know that it's going to open down like this. Since it does not have a domain restriction, it does not pass the horizontal line test. Therefore, when it's reflected about the y equals x line, it will not be invertible. All right, next question comes from Ryan, and it says simplify the following expressions. So remember with radicals, you just can apply distributive property, and this is kind of what I was talking about like with algebra too. Like it doesn't matter if it's radicals, doesn't matter if it's going to be logarithms. You end up just doing a lot of the same processes as before. So here, whenever you're multiplying a number, like you can only multiply the numbers outside the radical, and then only the numbers inside the rad again. So 5n times 5 is going to be a 25n. I have nothing to multiply the square root of 10 by, so I'll just leave it there. And then when I multiply here, I get a 5, and square root of 10 times square root of 2 is going to be a square root of 20. Well, that's plus. And then you can simplify the square root of 20 into, you can break that up into 4 times 5, which is 2 radical 5. So therefore, I can do 25 square root of 10 plus a 5 times 2 radical 5. So it's a 25 square root of 10 plus 10 radical 5. Over here, you just get a square root of 12 plus 2 square root of 6, right? Just distribute. All right, question number 10. Hey, Khalid, how are you? Sad fashion, Nava. Anyone how to graph linear equalities? Yeah, just graph them like linear equations and then use test points. The best test point to use is 0, 0. If 0, 0 is true, that means all the other values above or below that are going to be the same. That's a free question for you. I didn't even write it down. Hey, Summer Grace and Average Gamer, thank you very much. Let's see what else we got. Any other questions? McLogan, do you call out super chats? I do, Ethan, and thank you so much for joining in. Hope you are studying up for that exam coming up. And yes, I do call out super chats. No, I hope I didn't miss any super chats, did I? All right, how do you create the best cheat sheet? That's a good one. Should I make a gaming channel? Sure, why not? All right, so let's talk about this one for cheat sheets. It's my, okay, so cheat sheets. Okay, so when I'm doing a cheat sheet, I think some of the major things that you're going to want to, I think examples is so helpful. I think if you go through examples in your notes, go through examples in your book. Like I don't teach out of a book, so my students kind of unfortunately don't really have the best examples for that. But I have a lot of notes. I have a lot of examples for them. So I would go through your notes, go through the book notes, book examples, go through your tests. Tests are awesome. Tests, quizzes, right? And what I mean by like writing them down, like write down that information, like put it down there so you can remember, like, so when you do have a question of like completing the square, like, you can go back and refer to that and be like, okay, how do you do it again? Because like, yeah, formulas and definitions and processes and theorems, like those are all great. But in reality, if you have to like read those, like you're just, it's going to take up too much time than it's really worth, in my opinion. I think it's very helpful to have, some things that when you're doing a cheat sheet, it's got to be something that you can do with like a quick glance. Okay. And glance, I don't know why I put an L there. But it's got to be a quick glance. It's got to be something that you can look at this and be like, okay, yeah. It's not something like, how do I, learn how to do this by looking at my cheat sheet? Like that's not going to be something very beneficial at all. You got to make sure that when you are creating this, that it is organized, that it's something you can follow. So making sure that it's very organized, like, students always think that I'm like, oh yeah, you can just put whatever you want on your cheat sheet. They're like, what, seriously? And they like completely fill it up like as busy as it can possibly be. Like that's not going to help you out, So make sure it's organized, make sure it's clear, right? Make sure it's concise. You know exactly where to find everything and you understand everything. I think those are going to be, I would definitely just kind of focus on that. But I think the examples, theorems and definitions, like formulas, I think are important. Because a lot of times you're going to remember, you're going to forget the formula. So I think having some good formulas there is always helpful. But yeah, and then I would just maybe even do like some color coding. Those are always some special things to be able to do as well. All right, so let's go ahead and move on. I don't know why I did not give this work anything. So the next one says, is if the factor polynomial, if the factor f of x is a polynomial, find the other factor. So since my factor is quadratic, I'm going to have to use long division. And I'm like, yeah, that's why I was like, why didn't I give myself work to do this one? So that's a minus 5x plus 6. So let's do some long division here. Sorry, Marianne. Hope I don't get in your way. X cubed minus 9x squared plus 26x minus 24. Okay, so if this divides into this and we're going to have a factor, then all we need to do is factor that down. Like for instance, if I said like 4 is a factor of 12, right? It is a factor. Actually, let's do this. If I said 3 is a factor of 12, right? What are all the other factors? Well, you say, well, 3 divides in 12 4 times. How else can I break down 4? Well, you could say 4 is 2 times 2. So you could also say 2 and 2 is also a factor, right? So that's basically what we're going to be doing here. So to use long division, you're always going to divide from your first term. X squared goes into x cubed. X times x squared is x cubed. X times negative 5x. Sorry, guys, I'm just going to go through this a little bit quicker. X times 6, so you multiply your quotient times every term in your divisor. X times 6 is going to be a positive 6x. Then you go ahead and subtract your rows. Subtract everything, okay? You can put a little 0 here if you want a placeholder. So that's going to divide out. That's going to be a plus. That's a negative 4x squared. This becomes a positive 20x. And this becomes a negative 24. Okay, and then once you've done that, now that's one round, then you just keep on going. So how many times is x squared divided into a negative 4x? Well, that's a negative 4 times. 4 times x squared is a negative 4x squared. Negative 4 times negative 5x is going to be a positive 20x. And negative 4 times 6 is going to be negative 24. And you subtract your rows, and what do you know? Everything goes down to 0. 0, 0, 0, right? X squared, x, whatever. It doesn't really matter. It's all zeros. So my other factor is x minus 4. There you go. The next one is from Marianne. She said graph g of x, negative 2x squared, and h of x, 3x squared. So I'm not sure what course you're in as far as how detailed you need to be. I was actually just talking about a problem like this with my Algebra 2 class. And I don't like to be very detailed with them, but one thing I did tell them, like when you create a table of values, if I wanted to graph x squared, okay, it's very important you guys understand, like you just plug in the x value and then find the y value, right? So if I plugged in negative 2, I get positive 4. Negative 1, I would get a positive 1. 0, I get 0. 1, I get 1. 2, I get 4, right? So this is the relationship is over 1, up 1, over 2, up 4, over 3, up 9, right? Now that's for the parent graph. So if I have 3, all I'm going to do is multiply these values times 3. So if I go over negative 2, I'm going to go up 4 times 3, which would be up 12. Negative 1 here is going to be now times 3. So that's going to be up 3, 2, 3. And that's the same thing for over 1, up 3, right? So you can see, oh, 0, 0. If you multiply 0 times 3, that's going to still work. Okay, so if I did this by a 3x squared. That would be my values right there, okay? Now, what about if I multiplied all these y values by -2? Well, then, now this would be, instead of over -2, instead of going up 4, it would be down -8, right? Because 4 times -2 is -8. Well, I don't want to go and graph all that. Let's just go from here. So instead of going up 1, I could go down 2, right? 0, 0 is still going to be that, and then 0, 0 from there. So this one's just going to be a little bit wider. My graph's not going to be perfect, but hopefully you kind of get the idea. So hopefully that at least helps you out a little bit. Number 13, I left at this one. So I got a question from Derek, who says, find the vertex of completing the square. And the next one comes from Ahmad. So I was like, okay, I'll just do a random completing the square problem. And then I get one from Ahmad. It says, basically, be more specific and do the completing the square when x is not equal to 2. And I was like, ah, dang it. Okay. So I will do 2 completing the square problems, because let's just go through this one really quickly, because that was the one I did quick. X squared minus 8x plus 22. So y equals x squared minus 8x plus 22. Ah, I got a good question. Okay, so basically, what we need to do is we need to create a perfect square trinomial. Now, what I was doing in my head, I was saying, what perfect square trinomial do I want to create with these first 2 terms? Okay, and if you think about this, x squared minus 8x plus 16, that is a perfect square trinomial. That can be broken down into a binomial squared. So what I want to do is I wanted to create a value that's going to create that perfect square trinomial, which in this case was a 16. Now, if you didn't understand that in your head, you could always take the middle term, b divided by 2, and square it. -8 divided by 2 is -4. -4 squared is 16, right, in this case. So what you do, or what I did, is I went ahead and say, all right, well, let's take this 8x squared and let's add a 16. But again, you just can't randomly add a 16, right, to an equation without subtracting the 16 to the same side. Okay, so again, to keep the equation balanced, that's what you need to do. And then in this case, I know what this factor down is, which is a x minus 4 quantity squared, and then 22 minus 16 is going to be a positive 6. Now the vertex, in vertex form, y equals a times x minus h quantity squared plus k. The vertex is hk. So the nice thing about completing the square, by putting it into vertex form, you can use find the vertex rather quickly. Now, let's go into something a little bit more difficult. What if I put a -2, or let's just put a -2x. What if I put a -2x squared in front? Well, you can't do the same thing. Okay, you can't find this perfect square trinomial with a -2 in front. So what you need to do, there's a couple different ways you could do this, but what I'm going to do, actually, so what I'm going to do is you need to get rid of this -2. So I'm going to divide a -2 on both sides. So I have a y divided by -2 equals a x squared plus a 4x minus an 11. Now we say, okay, so now what perfect square trinomial do I need to get with a x squared plus 4x? Well, again, let's say you don't know. So you could take b, 4 divided by 2 squared. 4 divided by 2 is 2. 2 squared is 4. Right? So y divided by -2 equals x squared plus 4x. Come on. Plus 4. And again, you just can't randomly add a 4 to an equation without subtracting that 4. Okay? Now, this produces a perfect square trinomial. Hopefully you recognize this one. So y divided by -2 equals, let's see, an x plus 2 quantity squared, and this becomes a -15. Well, now you're just going to multiply that -2 back, right, because you want to solve for y. So it's a -2 times x plus 2 quantity squared. And let's see, -2 times 15, you need to multiply that -2 times both of those, and that's going to be a positive 30. So there you go. So that's the kind of difference here when you have a in front of that x squared. All right, another open kind of question. So let me know, guys, if you do have any questions. I do see a Jack Joe. We'll just do the translations. That should be good. Oh, you're helping somebody out. Well, good for you. Thank you so much for that. How do you graph a vertical stretch for a quadratic like that? Well, again, so again, it's important to understand, so right now you have a lot, well, you have more than the vertical stretch, DS void. That's not just a vertical stretch. You have not only a vertical stretch, but you also have a horizontal compression of 7. So the best thing I would do for you is to create a table. Okay. You just have to create a table of values. What you're going to want to do is find the axis of symmetry. and which for your case is going to be a -3/7, and pick 2 points to the left of that, and then pick 2 points to the right of that. And you're just going to have to plug them in. But you are not going to want to use the method that I just showed, how to do a quick graph on that. That wouldn't really be good advice for your problem. Your problem's a little bit more advanced. So for you, I would just plug in some points. I'd probably pick like -1, -2, and obviously it just has to be to the left of -3/7 actually. So you got to plug them in. Plug in an x, find the y, and then plot those points. That's what you have to do. Plug in the x, find the y, and then plot those points. Saw you're live, and I just want to say thank you for your YouTube videos. Well, you're very welcome for that, Tamili. I'm very happy to help you out. William says, is it only me, or do you guys ace every page and you mess up one question that's worth the most and you drop like 9%? I can definitely relate. Yeah, and I my students this year, they're taking their tests are only 18 questions because we're doing shorter periods, and yeah, it kind of stinks, if you make like one mistake, even like a silly or a stupid mistake, that brings down your grade like quite a bit. So I did like when we had bigger class periods and students could take more time, and I could give them more questions, so their grade just didn't bomb from on there. Just why I'm just going to give I obviously are confused. So I'm just going to give you a tips. Like, you have to plot your points since nobody else is asking a question. So you need to know the vertex, right? So, well, first of all, you need to factor out this. It's kind of a little confusing in this case. Hopefully you have to factor out that b. So I don't want to like overly confuse you here. Squared plus 3. Okay, so your vertex is going to be at a -3/7, which is a decimal, which is like kind of difficult for you to like graph. Okay, but again, like that's fine. All right, so it's -3/7. So -3/7 is going to be less than 1, right? So here's -1. So -3/7 is like somewhere here. I'm just doing randomly, and then that's a +3. So 1, 2, 3. Okay, so that's x equals a -3/7. So what I was telling you is you got to pick points to the left and to the right. So why don't we pick 0? Okay, so we have x value and a y value. All right, we know that is our vertex right there, okay, which is at -3/7. So you have to factor out that b to find the h and then your c. And then just pick points. Pick 2 points to the left and 2 points to the right of your axis symmetry. So let's pick 0. I'll do 1 for you. So if I plug in 0, so what happens when you plug in 0? Well, that's going to be 2 times 7 times 0 plus 3, y squared plus 3. Okay, so 7 times 0 is 0, plus 3 is 3, 3 squared is 9, 9 times 2 is 18, plus 21 is 21. So that point is 21. So you're 0, you're going to go all the way up to 21. Like, it's very, very high, right? And then let's say you plugged in -1. Okay. So if you plug in -1, which is kind of weird. Oh, -3/7 would be a little bit closer. Okay. If you plug in -1, let's do that. So let's do f of 0. Let's do f of -1. All right. So you plug in -1. So that's going to be 2 times 7 times -1 plus 3, y squared plus 3. All right. 7 times -1 is -7. Plus 3 is -4. -4 squared is 16. 16 times 2 is 32. Plus 3 is going to be 35. So yeah, that's going to be another like really, really high point, right? Like even higher. Whoa, oh my God, I'm missing my super chats. Jeez, oh man, you guys give me, how did I miss these? Who gave me a super chat? Did I miss? Thank you so much, guys, for a super chat. I can't believe I missed. I didn't even see this from that. Oh, well, Max, thank you so much, Max. I greatly appreciate that. And I hope you had a great time not great time, but I hope my videos and as well as instructions have helped you with your understanding of that. I guess when I was getting deep into that, I didn't see it. So thank you so much for that. And then Jen S., thank you so much for your help. I just finished my semester. Jen, awesome for you. Congratulations. I know it is a great feeling to be finally finished with a course, or maybe it's like your last math, or at least just done with this semester. Obviously a semester like anything else. So thank you so much. I really do appreciate that. And I wish you the best of luck now moving on into your educational journey. But kind of going back before I get distracted, sorry about that. I also got to give obviously got to give some love to people for the super chats. I do appreciate that. No, not that. Yeah, there we go. Just wanted that. There you go. So then, you know, if you have point to the left and to the right, I said 2 points, but 2 points might be a little kind of crazy from there. So this is it looks something like that, roughly. I mean, that's not a very nice graph that you had me graph. I'm just going to tell you that. All right. So let's go ahead and move on from there. So hopefully that helps you out. Oh, this was from Ceiling Panda. This was an interesting question. I'm not really sure. If you're helping another person study for a test and you're pretty sure they won't make it, would you recommend them briefly learning every relevant concept, learn a few more deeply, or anything else? This is not part of it. I think I didn't really like deeply think of this, but I think just like kind of reviewing what they know and then just seeing how far they can go. I don't think it's really worth it to go like deep into a concept. I think it might be, as far as like taking an exam and seeing what you can do, I think it's best to just study as much as you can do, not to go like overly in depth on one single topic, but just to review as much of the content as you possibly can, even if it's at a surface level understanding. And then, yeah, see how it goes for the quiz or for the exam or for the test. But yeah, now thinking about that, I don't think it's really worth your time to spend so much time like really making sure you know how to do like one problem. You know, like for instance, here, like this example, like here's one problem, right? You know, it's like, all right, making sure you know the trick, like, but who knows on a test or exam, like how many of those questions are going to show up, you know, and how they're going to be weighted and everything like that. So I think it must be better just to cover as much content as possible. And then hopefully based on the exam that, you know, you'll be able to kind of think through and work through some of those problems. All right, so let's get back into the questions here because I do have a post game that I'm doing for my members. I saw Addie went in and put into that. So I did have a post game kind of thing that I also do some extra questions after this live stream in my YouTube membership. So that's some things I'll talk to you guys about a little bit later on, but that's something I am doing, changing some of the things that I've done in my YouTube membership. For those of you guys that still have questions I don't get to, I apologize. I know it's not right for everybody, but I wanted just to let you guys know that's one of the things I'm going to start trying to not go as long for these live streams, but I don't want to blah, blah, blah. Let's get on. All right, so the next one says, determine the exact values of the other 5 trigonometric ratios on their given the conditions. Okay, so the first example we did a random triangle, right? And I just drew a triangle in space. But this one has a angle, but the angle is restricted between pi and 3 pi halves. So we need to understand that, right? Here's pi and here's 3 pi halves. So my angle needs to fall within those parameters. Okay. There you go. So that's going to be our triangle. Now this is very important because if I'm looking at the sine, oh, pi halves and pi. I was wondering about that. I'm like, that's wrong. I read that wrong. The question says between pi halves and pi. Okay, so the triangle looks like this. This is very important because you might say, oh, all right, well, that's 3 and that's 5, right? And there's theta. Yeah, but if you notice there's a Pythagorean triple, like that other example. But since you're going to the left, that's a -4, okay? So the sine of theta is 3/5, that's right. But the cosine of theta is a -4/5. That's why this is so important. That's called our constraint. If we didn't have that, everything would be positive and it would just be in space. But once we have that, it now puts us on our XY axis, and now our sines are going to become important. Or not really important, but they're going to become relevant to the problem. So now I have tangent of theta is going to be opposite over adjacent. So that's going to be 3 over a -4. Let's see, I got my cosecant, which is the reciprocal of sine. So that's going to be hypotenuse over opposite. And I have secant of theta, which is going to be my reciprocal of cosine. So that's going to be -5/4. And then I also have cotangent, which is a -4/3. All right, so here's another identity at eWang that posted this question. And let's go ahead and give it a shot. See what we got this one. So I recognize this question. So that's why I was like, hey, you know what? I'll go ahead and give this one a shot. But I'm not sure if I remember from this one, or at least from there. So if we're, or I'm not, like, I haven't done this problem. Well, we're not covering this topic yet. So we'll see how it goes. All right, so one thing I remember though is if you are going to be adding fractions, you need to have common denominators, right? So since these do not have a common factor in between them, I know that the common denominator is going to be a product of them. So therefore my LCD in this case is going to be equal a 1 plus sine of x times a cosine of x. Okay, so that's going to be my common denominator. So what I'm going to do is I'm going to multiply over here by cosine of x over cosine of x, and here times 1 plus sine of x times 1 plus sine of x, right? Because our goal here is to make the left side look like the right side, right? Obviously, the left side is much more complicated than the right side. So over here, I get a cosine squared of x. This is going to be a binomial expanded, so it'd be 1 plus 2 sine squared of x plus sine squared of x all over my common denominator of cosine of x times 1 plus sine of x. Okay, remember your Pythagorean theorem, sine squared of x plus cosine squared of x equals 1. So therefore, these two give us 1. So that's going to leave me with a 2 plus 2 sine squared of x all over a cosine of x times 1 plus sine of x equals a 2 secant squared of x. And then you can factor out the 2, so therefore that's a 2 plus 1 plus square root of x, right? So therefore, that gives you a 2 cosine of x, which it would then be verified from on there. So you can see that I just went ahead and simplified this. So that'd be a cosine of x times 1 plus sine of x. So that's how those go ahead and divide out, and you can go to that form. All right. Next one. Hagibus, I believe, maybe. How many more questions I got? Oh, I don't think I got. Oh, I only got 2 more. Okay. So you asked if angle A is an acute angle and tangent of A is square root of 6 plus 2 and square root of 6 minus 2, find the cosine of A. So again, here's another triangle that here's another one that we have. Like, it's just in space, right? There is no restrictions here. Okay. So, tangent, remember, is opposite over adjacent, right? So we have opposite, which is square root of 6 plus 2. And we have adjacent, which is square root of 6 minus 2. Okay. And then we have our hypotenuse, which we don't know. Let's just call it R. Well, if I need to find cosine, remember cosine, guys, is going to be adjacent over hypotenuse, right? So that's going to be adjacent over hypotenuse. Okay, so to go ahead and do this problem, what I need to do is I need to figure out what R is. So I'm going to say that's going to be the Pythagorean theorem, right? So I'm going to say square root of 6 plus 2, cosine squared, plus the square root of 6 minus 2, cosine squared equals R squared. All right, so if I was to expand this binomial, that would give me a 6 plus 2, that'd be a 4 square root of 6 plus 4, plus, if I was to expand this, that'd give me a 6 minus 4 square root of 6 plus 4 equals R squared. Okay, so therefore these are going to add to 0, and this would be 4 plus 4, or 6 plus 4 is 10, so it'd be 20 equals R squared, and then square root. So therefore R equals the square root of 4 times 5, right, which is 20, and that's 2 square root of 5. Okay, so now I know what R is, and I know the adjacent side, right? It doesn't matter where your angle, well, actually it does, opposite, so that's opposite, so let's call it here as our theta angle. So, or actually, let's call this A. That's the angle. So we could say the cosine of A is going to equal adjacent square root of 6 minus 2 divided by 2 square root of 5. All right, and then you could obviously simplify this a little bit further if you needed to. Square root of 6 minus 2 divide 2 square root of 5. You could rationalize the denominator maybe. And that would maybe give us a, let's see, then you'd have to distribute that though. Square root of 30 minus 2, square root of 5. Square root of 5 times square root of 5 is 5. 5 times 2 is 10. And there you go. That'd be just another variation. So that should work, and that may be another one. All right. What's up, Jacob and Vishwas? Hunter? Oh, Hunter, what's up with that? Jesse, let's see. Anash, cappuccino, enough. Good to see you guys on. Thank you so much. Chili Diamond, thank you for all your help. You are very welcome. Denominator is sine. The numerator is sine squared. Wait, you can't cancel them out like that, right? I'm not sure what you're talking about, Haran. No, you cannot divide out the signs from like that. What I had to do, and actually, you know what? I hate when I might as well just like break this one down. I'm not sure if this is the problem you're talking about or not, but it should just be, there you go. So I factor out the 2, divided those out, and that's where I got 2 of cosine, which is obviously just going to be secant, right? 1 over cosine is sine. So hopefully that helps you out. Man's really solving equations for an hour. Yes, I have. My head's starting to hurt. Well, thank you, Blessings, John. I really do appreciate that. Sophia, I need to pass my pre-calculus final on Tuesday. Sophia, you got this. You can do it. Garcia, well, hey, Garcia, how are you? How many triangles? Oh, God, I hate those questions. Come on. All right, well, you did post a question, and that is easy to do. So, hey, Jolly. All right, so how many triangles? Come on now. C, A, and B. So side, side, side. All right. So you have C equals 33, A equals 24, and B equals 11. Okay. So what I like to do in this case is I like to draw the triangle. All right. And I'm going to say, here's my angle 33. Here is my A, which is 24. And here's my B is 11. Okay. And what we're going to do is we're going to find the height. Okay. So to find the height, kind of the same thing. If you were to kind of take this triangle here, that is going to be, so that's 33 degrees. You can say the opposite over hypotenuse. So you can say the sine of 30 degrees is going to be h over 24. Okay. So h equals, let's go ahead and do this. So make sure your degrees, your mode is in degree mode. Okay. So I'm going to do sine of 33. And then times 24. And that equals 13.07. Okay. So if that's at 13.07, that's longer. If that's shorter, yeah, there's going to be no triangles. So that's from the previous terms. How many triangles? There is going to be none. Okay, because again, that's a 13.07. Well, if your opposite side is 11, that's not long enough to make a triangle, right? If this is 13 and that's 11, that's never going to make a triangle from there. So I can do more justice, and I have many other videos that explain that, but hopefully that kind of makes sense, or that's something you're looking for from there. All right, guys, I got to go and get into my YouTube members stream, so I'm going to kind of go through this one rather quickly. But thank you so much, guys, again for joining in. And remember, you can always check me on my next stream at Sunday, 9 p.m. and post your questions in the Google chat or in my description below. So the sine inverse. So the sine inverse is of sine of 6 pi over 7. And the student was asking, like, do these undo each other? And the question is, yes, they do when they're positive and then in the first quadrant. So you need to understand, like, sine of 6 pi over 7. Like, what is the sine of 6 pi over 7? Well, that's the y-coordinate, right, at 6 pi over 7. So we say, all right. So 6 pi over 7 is, if we were to break this up into 7 equal parts, right, this is pi, which is 7 pi over 7. So 6 pi over 7 is somewhere right there, right? Now, again, what we're looking for is like the y-coordinate. Now, I have no idea what that y-coordinate is for that angle. Agreed? I have no idea. So, but I do know then, if I'm going to use the sine inverse, which is, again, looking for my angle, my answer has to be between negative pi halves and pi halves. So the only other angle that I know that's going to meet this restriction, that's going to have the same y value, is going to be the one that's in the first quadrant, right? So that's going to have what we call the same reference angle. So if here's your angle, this is going to be your theta prime. Well, that's also going to be the same reference angle. And I'm not sure what I was getting for with that. But again, yeah, so what's the reference angle of, so if theta is 6 pi over 7, then what's theta prime? That's going to be pi over 7. So therefore, this answer is going to be pi over 7. So there you go, ladies and gentlemen. Thank you so much for joining me on this evening. I look forward to seeing you guys on the next live stream, which will be streamed next Sunday night at 9 p.m. Eastern Standard Time. Again, guys, as you have questions, please feel free to go ahead and submit them in the chat down below in the description, and I look forward to answering them and helping you guys out. Also, if I don't get to your questions or you want to go ahead and submit them into Discord, go ahead and join that community. There's a lot of great people out there that are helping people out, answering their questions, and feel free to also do the same in there. So, all right, guys, have a great night, and I wish you the best of luck if you still got those exams, and congratulations if you are done for the year. Peace.